Hi, welcome back. In this video, we're continuing to look at graphing exponential functions, and we are going to graph an example. So we have our parent function here and an explanation of our transformations, and we're going to use an actual function. So here we have 2 times 3 raised to the x minus 1 minus 4. So the first thing I like to do is I like to identify the base of my function. And in this case, this value here, I'm looking for whatever's raised to the exponent, so my base is 3. 3 is bigger than 1, so I am going to be looking at an exponential growth situation. So I'm going to be looking at a graph that looks like that. My a value is positive 2, so it's going to be vertically stretched but not flipped. My h value is x minus h, so my h value is positive 1, and my k value is negative 4. So I'm just going to kind of identify those things and help myself out there. So we want to kind of remember back to kind of what was happening with our graph. This graph had a horizontal asymptote at y equals 0. That same asymptote is present, but we've now moved our graph down 4. So this k value is actually going to shift my entire graph down. So this horizontal asymptote now becomes y is equal to 0 plus k. All right, so my asymptote is now going to be at y is equal to negative 4. So 1, 2, 3, 4. I'm going to graph the asymptote with a dashed line. And I'm going to label it. This is really important. You must have the asymptote graphed and labeled for this graph to be considered complete. So when I'm thinking about the domain of these graphs, there are no restrictions for what I can put in the exponent. So my domain is going to be from negative infinity to positive infinity. And as I'm thinking about the range of this function, this 3 to the exponent will always be a positive number. So I'm going to be looking at 2 times a positive number minus 4. 2 is a positive number, so I have a positive number multiplied by a positive number minus 4. This means that whatever I have is going to be bigger than negative 4. This is always going to be positive, so my graph is always going to be above this. So this is my range. So in this case, my range is from negative 4, not included, up to positive infinity. Because this is always positive, this whole thing can't be less than negative 4. So that's where my range is going to be. We can also get the range after we've finished graphing it. So I like to use this to help me figure out what my graph should be. I don't like to just pick random values to put up here. I like to try to make my exponent convenient things. So my exponent is x minus 1. I'm going to try to make that exponent negative 1, 0, and 1 and graph those 3 points. We need 3 points and an asymptote to graph this. So if x minus 1 is equal to negative 1, x is equal to 0. Okay. So if I plug 0 in for x, I'm going to get 2 times 3 to the negative 1 minus 4. So that is 2/3 minus 4. I am going to get negative 3 1/3. And I'm going to write it as a mixed fraction here. I don't usually like to do that, but I find it to be a little bit easier to graph. So I have 0, negative 3 1/3. So 0, negative 3 1/3 is right there. All right, so if I want the exponent to be 0, x minus 1 equals 0, x is equal to 1. So if I plug 1 in up here, I'm going to get an exponent of 0. So that's 2 times 3 to the 0 minus 4. So that is 2 times 1. So 2 minus 4, this is negative 2. So I'm looking at 1, -2. And then if I want my exponent to be 1, I should plug in 2 for x. So if I plug 2 in for x, 2 minus 1 is 1. So this gives me 2 times 3 to the 1 minus 4, which is 6 minus 4, or 2. So now I have the point 2, 2. And when I graph this, you see I've got the asymptote here and I have 3 points. I'm not going to connect them as a line. I'm going to connect them and go up like that as a curve, and then I'm going to follow them down and approach but not cross that asymptote. So this is the point 0, -3 1/3. This is the point 1, -2, and this is the point 2, 2. I have my domain that x can be any value. I have my range that y values will be always greater than -4, and my asymptote is at y is equal to -4.